Okay, so our job here is to figure out the value of x, to figure out the value of y, and to figure out the value of z. And then the problem states, and by the way, this is 6-90, part D. The problem states that we can choose which of these two shapes is the original and which of these two shapes is the new. So right now I'm going to leave that up to you. Which one do you want to be the original? The small one or the big one?
The big one.
Big one? Yeah. All right, we can make the bigger one the original. So we'll go bigger one original. So let's label it original. Then that means the smaller one will be the new. Once we have this, our next step is to figure out what? The scale factor. We need the scale factor. So, to figure out the scale factor, we're going to use a very, very simple formula. New over original. Now, for our scale factor, we actually need numbers, right? Yeah. So we need to find two corresponding sides that each has an actual number. Yeah. So which sides do you want to use? 6 and 4. Okay, so we're going to go with 6 and 4. So now let's look. Which one of these is the new? The 6 or the 4? 4. So 4 will go on top, and then 6 will go on bottom. So it'll be 4 over 6. And when we're looking for a scale factor, we want this reduced to its lowest terms. So this is going to turn into 2 over 3. And there's our scale factor. This is what we're going to be working with. That scale factor, this guy right here, is going to help us find this side, x, this side, y, and this side, z. And all we got to do is follow a very simple formula. So we're going to go with original times scale factor equals new. And now let's try to determine the value of x. So if we're trying to determine the value of x, we need a corresponding side to x. So which side corresponds to x? 6, right here. Between these two, which one's the original? X or 6? X. So x must go right here with the original. So we're going to go x times the scale factor. What's our scale factor? 2 over 3. We've already labeled our scale factor, ladies and gentlemen. It's right here. 2 over 3 equals our new side. Which one's our new side? 6. Okay. Well, x times 2 over 3 becomes 2 over 3 x equals 6. But I want to get rid of this fraction. So what should I do to the entire equation? Multiply by what? By 3. I'm going to multiply this by 3, and I'm going to get, what happens when I multiply 3 times 2/3? What do I get? 6 over 3, right? X. Because 3 times 2 is 6, and then there's a 1 underneath that 3, right? So 1 times 3 is still 3. Now, I got to multiply the 3 times the 6, because I'm multiplying the whole equation, so this equals 18. What's 6 divided by 3? 2. So now this turns into 2x equals 18. Divide both sides by 2. X equals 9. And we're done with that side. We got one side. X equals 9. Okay, so next we're going to try to find the value of y. And we're going to use the exact same formula. Original times scale factor equals new. And we're trying to determine the value of y, so we need a corresponding side to y, which would be what? 12. Now, between 12 and y, which one is the original? 12. So 12 must go here. So we got 12 times our scale factor, which is 2/3, equals our new side, which is y. So now let's multiply. What's 12 times 2? 24. So I'm going to get 24 over 3 equals y. What's 24 divided by 3? So y equals 8. And we're done with that side. So far, so good?
Yes.
Okay. Now we got to determine the value of z. And I'm going to do that over here, and I'm going to use the exact same formula. Original times scale factor equals new. So we're trying to determine side z. Z corresponds to which side? The top. So this right here is 5.7, right? So between 5.7 and z, which one is the original? 5.7. So 5.7 goes right here. So this becomes 5.7 times the scale factor, which is 2 over 3, equals z. So what's 5.7 times 2? 11.4. Over what? Over 3 equals z. What's 11.4 divided by 3? 3.8. So the value of z is 3.8. And now we've figured out the value of x, the value of y, and the value of z. And all we had to do was decide which shape was going to be the new and which shape was going to be the original. Then we figured out the scale factor. Once we had the scale factor, all we do is follow this formula, original times scale factor equals new, and you can find the value of x, the value of y, and the value of z. But now we're going to do this in a different way. So here's what I need everyone to do in the next 1 minute. In the next 1 minute, right underneath all this work, or wherever you have space in your notebook, I want you to redraw the original shapes all over again. So let's take 1 minute to do that, and I'm going to press pause on the video. Okay, so now we're going to do this a whole different way. And what I mean by a whole different way is, in the last version of this, we made the bigger one the original and the smaller one the new. In this version of this, we're going to make the bigger one the new and the smaller one the original. And you're going to see that we're going to get the same thing. Here we go. So the smaller one will be original. The bigger one will be the new. And we should get the same thing. The only thing that's going to be different is going to be our scale factor. So, speaking of the scale factor, let's get that scale factor right now. So, scale factor still follows the same formula. New over original. And again, we're going to use these two sides because they correspond to each other and they actually have numbers, right? So, this time it's going to be 6 over 4. And it makes sense, and I'll tell you why it makes sense in just a bit. So, we're going to go equals 6 over 4. And if I simplify this, this becomes 3 over 2. Or, if I want to put it as a decimal, I go 1.5. So our scale factor is either 3 over 2 or 1.5, whichever we want to use, right? Hey, by the way, both 3 over 2 and 1.5 is the same number, right?
Yeah.
This is higher than 1. Do you agree?
Yeah.
And it makes sense that our scale factor is higher than 1 because our shape went from becoming small to becoming big. So our scale factor should be bigger than 1. On the last one, our shape went from being big to getting smaller, so the scale factor had to be less than 1. Does that make sense?
Yeah.
Okay, here we go. Now we're going to figure out the value of x. We're going to do the same thing. We're going to follow original times scale factor equals new. And we remember that the side that corresponds with x is 6. So between these two, which one's the original now? 6. So 6 goes right here. So we got 6 times the scale factor, which is 3 over 2, equals x. Because that's the side we're trying to get, right? So what is 6 times 3? 18. So this becomes 18 divided by 2 equals x. And 18 divided by 2 is, so the value of x is still 9. Just like we got last time. Last time we got x equals 9. This time we still have x equals 9. Alright, now let's go with y. Original times scale factor equals new. So between y and the corresponding side, which is 12, which is the original? Y. So y goes right here. So now we have y times 3 over 2 equals 12. So our equation becomes 3 over 2y equals 12. What am I going to do to 3 over 2y equals 12? To the whole equation? Multiply by what? 2. By 2. So now I get, what's 2 times 3? 6. So this becomes 6 over 2y equals 24, because 2 times 12 is 24. What's 6 divided by 2? 3. So this becomes 3y equals 24. And so, yeah, this is y equals 8, because if I divide both sides by 3, I get y equals 8. Agreed? Yeah. Okay. And on the last one, we also got y equals 8. So even though our scale factor is different here, we're still getting y equals 8 because we're following the exact same formula. Does that make sense? Yes. Last one, z. We're going to follow the formula again. We're going to go original times scale factor equals new. So now we're trying to locate or determine the value of z. Z corresponds to 5.7. Which one is the original, z or 5.7? So I'm going to go z times, instead of 3 over 2, this time I'm going to use 1.5. See, I'm using the decimal version of it because 5.7 is a decimal. Equals 5.7. So now I have 1.5z equals 5.7. I divide both sides by 1.5. And if you have your punchy calculator, z is still equal to 3.8. And just like last time, z is still 3.8. So, whether you choose the bigger one to be the new and the smaller one to be the original, or you choose the smaller one to be the new and the bigger one to be the original, as long as your scale factor is done correctly, and you are labeling everything, and you use the formula original times scale factor equals new, you're going to be able to get every single side length you need. Give me a 1 if this makes sense to you. Give me a 2 if it doesn't. For those of you watching the video, everybody's giving me a 1 right now. I do not know if they're lying, but right now they are giving me a 1. Alright, make sure to click like and subscribe to the channel to earn yourself some homework passes. Hope this video helped. I'll see you on the next video, ladies and gentlemen.